Yes. See, laws of reflection, they'll ask the questions. What the question they will ask, like, what is the reflection of light? And explain an activity to prove that laws of reflection. So for that, first what you're going to take? What is reflection of light? Means the bouncing back of light, or any light which is just incidenting on the opaque object. What will happen? It will bounces back to the same medium. Okay, children. So that is what we can write the definition of the reflection of light. Bouncing back of a light into the same medium. Okay, our reflection back of light or coming back of a light into the same medium, what we call as a reflection of light. And the two laws of reflection, I think in the last class also we understand the two laws of reflection. The first law of reflection is that regarding the rays, all the rays, whatever a reflected ray, normal, and the point of incidence all lies in the same plane. And second law is regarding the angles. Okay, the incident angle, reflecting angle, how they're equal. Let us see with the little figure. Make it clear. So the mirror, what we can take for this activities, right? And the line which is perpendicular to the mirror, we can call it as a normal. And the line which is incidenting or striking on the surface called as incident ray. And the ray which is coming out and reflecting back from the mirror called as a reflected ray. And the angle between normal to the incident ray called as angle of incidence. And the angle between normal to the reflected ray, that angle what we call reflected angle. Clear, children? And here you can observe whatever the angle of incidence is there, this angle, let us take this is 40 degree and this must be 40. At what angle the ray will come and incident on the mirror, the same angle it will reflect back. Suppose you have the question that when the ray will incident normally, so that means the ray is coming along the normal. So what is the reflection? Here see angle is 0, right? Angle of incidence is 0 because it will here to here angle is there. Suppose imagine initially it maintains some angle. It is come to straight. Okay, this line will coming to here. What happen? It will go along the normal without any angle of incidence. Perpendicular it will go. The reflected ray also perpendicularly coming back. It won't go any deviation. It won't do any reflecting angle also 0 that time. Okay, try to understand. Angle of incidence is 0. Angle of reflection is also 0. It will again follow law of reflection. Okay, children. But it will come with some angle. What angle it will come with? The same angle, it just reflect back. So this is what we call law of reflection. And how are you going to prove this law? So just very small things required to prove this activity. One thing, just to take one table. Okay, children, on the table, just to keep one white paper. Just to take a table surface, imagine. On that, just to keep one white paper, like this, one white paper. And just draw mirror, just keep a mirror perpendicular to this paper. Okay, perpendicular, like vertically, you just keep on the table one mirror. Now take a light. Okay, children, use your laser light is possible or any light what is available. Try to make it collimate. Okay, suppose if a laser light is there, you just incident laser light on the mirror like this. Again, reflected ray will come back. Understood, children? Like that you can use. Or else if you don't have laser light, you have to make one cardboard and make a small stick. Through that, suppose you kept one bulb here. Through the bulb, all the rays will fall. It won't get reflected ray properly. So that what you do, use one cardboard, make a small hole. Through that whole light will follow like a laser light. Falls on the mirror, reflect back. Now, when it is going through this path, you just put a small pins or use a scale or pencil and mark a line. So let's imagine what you take on paper. On the paper, the line which is going light and fall on the mirror, just you mark this as the incident ray. And the ray which is coming, this is the mirror surface, imagine. Which are coming back, that is a reflected ray. Hope it is clear, children. Incident ray and reflected ray. And take your, in your geometry box, like this triangles are there, no? Protractor, two triangles are there. Like take one triangle and keep here and make one line perpendicular to the surface. Okay, the perpendicular line, just draw one perpendicular, that will be angle normal. Now take a protractor and put your protractor somewhere here and measure the angle. Here to here angle how much is there, and here to here angle what is there. This angle from normal to the incident ray gives you the angle of incidence, and from normal to the reflected ray gives you reflecting angle, what we call R. Okay, if you do that activity and try to do, it will get always angle of incidence must be equals to angle of reflection. That proves the second law of reflection, and you can observe that all lies in the sheet only, right? In the paper, what you take it, in the paper only incident ray is there, reflected ray is there, and normal is there. And the point of contact also there. That proves the first law. So two law of reflection you can easily prove using only one mirror and one laser light you have. If you don't have laser light, at least make one cardboard, make a small hole. It will be act like a single ray. Okay, children. So first law of reflection, the incident ray, right, and the reflected ray and the normal at the point of contact all lie in what? All lie in same plane. Okay, children, same plane they're going to lie. And the second thing what you're going to observe, the angle of incidence must be is equals to angle of reflection. This is the second thing what you're going to observe. Clear, children? Is it clear? Two laws of reflection, how are you going to prove? Yes. So angle of incidence is equals to angle of reflection. Yes.
Ma'am, can you explain the law of reflection once again, ma'am?
Oh, okay, dear. Yeah, see what are the laws of reflection you want to again. First law of reflection, that incident ray, okay, reflected ray and the normal at the point of contact. This is the point of contact on the mirror surface. All lie in the same plane. See, you can observe no, this and this. All lies in the same plane, one plane. And the vertical plane, you can see the mirror. So this all lies in the same plane. That is the first law. And the second law, angle of incidence is equals to angle of reflection. Suppose this is a 30 degree if you measure using the protractor, and this angle must be 30 degree. So that is the second law of reflection. Hope it is clear, the first law and second law. Clear, children? Yes. And see at what angle the ray will come and incident, at the same angle it will go back. So both angles always gives you the same value. Okay, children? In other words, you can tell in the normal words, the light gets reflected from the surface at the same angle when it hit it. Suppose when it hit with the angle of 30 degree, it will go reflected back also with the angle 30 degree only. So this is what regarding your now coming to the reflection, two types of the reflection you're going to observe usually in the all the objects. When you can see the clear images in case of like clear water and all. Yes, that's it. Yeah, in case of plain mirrors and in case of highly polished surfaces and in very new steel boxes or any smooth floor is very smooth, that time you can see the some a little bit amount of clear image you can see, right, children? So that is what we call regular reflection. Okay, the clear or regular reflection. Why it is regular reflection? How many rays will falling on the mirror? The reflected rays also comes parallelly. Incident rays will parallelly falls on the mirror. Reflected rays also comes parallel. These are the reflected rays. They also comes parallelly, and you can see that they are all under reaching your eye. Suppose you just incident ray direction, all they comes in the same direction, so that you can see them all the rays, so that you will get the information, all the information regarding the which object rays that they are. And here in case of diffuse reflection, you can see they're coming and falling on the because of different, normal is different. Here you can see here it is a normal, it will be normal like this. Here it is a normal like this, because normal changes. Suppose the contact surface changes, it will go like this. If the surface is like this, it will come and go like this. Okay, if the surface is like this, again it will fall and go like this. So because of irregularities of the surface is not smooth, it is a rough surface. In that condition, you cannot see the clear image. You cannot get the idea regarding, see here 4 amount of rays are falling. You will get only one ray, means it is just diffuse. This ray are just going to waste. You don't get the information regarding that rays. In that condition, you don't get the clear image, diffused image. You can see sometimes in your face in some boxes, steel boxes, it is like a diffused amount of image you get, right, children? So that is what regular reflection and irregular reflection. So differences between regular and irregular, they will ask one important question, children. You write the picture. This picture you will write and explain the two lens. Regular reflection will be occurring smooth and shiny surfaces. There you will get clear reflection and clear image you will get. Okay. And in case of diffuse reflection, it will be occur in a diffuse surfaces or irregular surfaces. In case of irregular surface, the surface is irregular. In that condition, you will get diffuse reflection. You not clearly see the clear image. You cannot get here clear image. Here you will get the clear image. Here you cannot get the clear image. Like that, 2 points you write the differences between the clear or diffuse, or we can also call as a irregular and irregular reflections. Right. Next, in uses of the mirrors, where you're going to see our uses of the mirrors in one thing is the periscope. Okay, children, the periscope we can able to see the images like this in case of periscope, and you can see spherical mirrors also in car headlights and ATM barns. In case of apartment, in front of the apartment, you want to see cover the large field of view. There and all we're going to use the spherical mirrors. Clear, children?